Welcome to our Integration Designer course. I'm Vincent Bova, Director of RTI Training. Today, we'll dig into RTI's Logic Helper driver. Logic Helper is a useful utility driver used to evaluate several variable statuses using logical operators. We'll cover how Boolean variables work, how logic gates can evaluate them, and how to use operators like AND, OR, NAND, and NOR to solve common problems in Integration Designer. Here I am inside Integration Designer. I'm going to show you a couple of problems that we're going to solve with Logic Helper. Now, I have a pretty comprehensive project, a couple of rooms, a couple of devices. I'm going to select my first room, the media room, and my first page. In this room, I have three unique devices: a television, an AVR or receiver, and a cable box. Now, I've already went and programmed the power toggle commands for all three. For the television button, this will use the driver to power toggle the television, and because it's a driver, we can show the reversed or press state of the button when the power variable or power on variable is true. For the receiver, same thing. We're going to power toggle the receiver, and when the receiver power status is true, the button will display its press state. Now with the cable box, because we don't have a driver for the cable box, we're going to send the power toggle using a plain infrared command, but we're also going to track the status of the cable box, since the processor can't pull it, with a flag. So when the flag will toggle from clear to set, or 0 to 1, or false to true when the cable box is turned on. And then when you press it again, it will clear the flag and toggle the power off. So three unique devices, different ways of controlling them. Now, where does Logic Helper come in, and how does this work? Well, Logic Helper has something called operators. And you can see some of the operators here in the logic gate table that we have here. AND, OR, NAND, which means not AND, and NOR, which means not OR. Now let's go over how we can use the Logic Helper in this case to figure out if everything is on, or if something is on, or the inverse. Okay? So we're going to use the Logic Helper driver to do that. So the Logic Helper will tell us, is the television, receiver, and cable box, are all three on? That will be the AND variable, meaning the television and the receiver and the cable box is on. The OR variable, and let's stay focused on AND and OR for now, is going to tell us if any of the three or more than one of these is on, or all three is on. That would be the OR variable. And the OR variable will be true when at least one of these items is on. So how do we program the Logic Helper driver? Well, I'm going to go to my Add Workspace. I'm going to go to my Driver tab and make sure my official library is selected, and I'm going to search for Logic. Here you can see the Logic Helper driver, and we're going to add that to the global area since we have other rooms in the project. We're going to select Next, and in this case, we're going to name the source the same as the driver. Now, Logic Helper will not create a page. We'll leave that checked, but it won't create a page for it, nor do you need one. Let's select Add Device and click Close. Now, the key to programming Logic Helper is to configure the driver properties. So let's take a look at the driver properties. I'm going to open up the tabs here. I'm going to select my Logic Helper driver and select Driver Properties. Now, in the driver properties, besides being able to designate a processor to run the Logic Helper driver, Right now it's set to master or main processor. What we're going to do is define a Boolean variable. We call it Boolean. It could also be called a proposed variable, but we'll call it Boolean variable. Now, in our case with our room, let's give that variable a name that we're going to be evaluating in that media room. So I'm going to call that media room power. That will be our Boolean variable. Now, underneath, you can track up to 16 variables using Logic Helper. In fact, you could even evaluate variables from Logic Helper, but we'll get to that a little later. What variables do we want to evaluate to tell using AND or NAND or NOR to set that media room power to true or false? Well, we want to evaluate 3 of them. We want to evaluate first and foremost our television power on status. And you can see now our second variable opened up, which is not set. Another variable we want to evaluate is our AVR. And we're just going to evaluate in this case, since it doesn't break out power on and off, the power state. Okay? Now, with the cable box, we're not going to be able to evaluate that with a driver, but the Logic Helper can evaluate the flags. So let's pick the XP macro flag. Let's pick flag 1, cable power, and we're going to evaluate that. Now, how does this work? How does AND or NAND and NOR work? Let's head back to our interface in the media room and take a look at our interface here. The way AND works, let's start with AND. AND is going to be true when all variables in this group of variables is true. So that media room power variable will be true if you're using the AND gate, if all 3 of these are true. If the television is on, if the receiver's on, and if the cable box flag is true, meaning the cable box is on. So how do you program this? Well, over here in our logic gate table, you could see the 4 different operators. Let's start with AND. The first thing I want to do is get a status of our AND variable. So I'm going to pick a macro level. I'm just going to go to our variable levels. I'm going to select a source variable. And in our text state, I'm going to set in our Logic Helper driver the AND operator and click OK. Now, right now it's set to false, and we could edit this value so that it will say something we decide to do when it's true or false. But when AND is true, what does that mean? Well, that means that the television, receiver, and cable box is on. All 3 of those variables that we included under the Boolean are true. Okay? So we'll call true all are on. And false will be all are not on. And click OK. And now this will tell us exactly what the status is for our AND gate check. Okay? Now we also have a reverse state button. And I want this to show the reverse state or light up to that green color when AND is true, meaning all 3 of these are on. So I'm going to go to my reverse state and I'm going to select my AND variable and click OK. So now we can evaluate if all 3 of these are on at any given time. If 2 of the 3 are on, well, AND is not true. AND is false. And the reverse state button will not light up. Now, what if some of them are on? What if 1, 2, or all 3, even all 3 are on? That is the OR logic gate. And OR means at least one of these variables is true. It could be 1, it could be 2, or all 3. For OR to be true, at least one of these variables or one of these devices has to be on. And we're going to program this the same way. We're going to click on the text tag. We're going to open up our variables, click on source, and we're going to program a text variable using the OR operator. And now this will say true or false. We could edit this value. If OR is true, at least one is on. If OR is false, well, none are on. And click OK. So the OR operator will evaluate if any of those variables is true. And now the Boolean variable will be true if any of the underlying variables that we set are true. Let's program the reverse state. So when this becomes true, when any of these are on, this will show its reverse state. Let's select this and select the OR. Now, if you know AND and OR, NAND, which means not AND, and NOR, which means not OR, are pretty easy. These are the inverse of AND and OR. What NAND means is that in this case, NAND will be false when all 3 are on. So AND is true when all 3 are on. NAND, or not AND, will be true when all 3 are off, or false when all variables are true. So let's program the text feedback. Let's open up our variables, and let's program the NAND operator and click OK. And now this variable is going to be false when all are on, and true when all are not on. So with programs, you can evaluate the inverse of AND and OR. Let's click OK. Let's program the reverse state for this light up button or this LED as well with the NAND check. What about NOR? Now with NOR is going to be false when one or more of these are true. It's the opposite of OR. With OR, if any of these are on, the OR variable becomes true. But with the NOR, the variable becomes false if any of these are on. So let's program the NOR. Let's hit source. Let's program our operator. And now let's edit our text. Now, when is OR NOR true? NOR is going to be false when one or more are on. And it's going to be true when none are on. It's the opposite of OR. And let's program our reverse state as well. Now I'm going to load up the system and let's check out how this all works. Let's communications, send to local devices, and let's start with our main processor. I'm going to change the target to our processor on the network, use select a device, and then send to our processor. Once that's done, we're going to send our virtual panel, which will create an executable anywhere we like. I'll put this on my desktop and save it. Let's launch it. And now, once our virtual panel comes back, once our processor is completely updated, we can jump to our first set of conditions. I'm going to click end. And now, right off the bat, none of these are on. So NAND is going to be true because all of these are not on. And NOR is also going to be true because at least one of these has to be on for NOR to be false. Now, what happens if I turn one on? Let's turn on the television. Now, OR is true because at least one is on, and NAND is true because all of them are not on. Okay? Now, what happens if I select the receiver as well? Same thing. At least one is on still, and all are not on. So NAND is true. Now let's see what happens when I turn on all three. Now all three are on, AND is true because all are on, and OR is true because at least one is on. NAND is false because all these variables are true, and NOR is false because none of these variables are true. Okay? So that's how you evaluate multiple variables using AND, OR, NAND, and NOR. Now, in this case, we could do other things with this. Let's do something else. What if I wanted to report some feedback up top? I'm going to take my text box here. I'm going to draw a text box. And now what I'm going to do is I'm going to put in a variable. And I'm going to put in a text tag first. And I'm going to use my OR variable. Okay? And now I'm going to click OK. Let's make the box transparent. Let's make our font a little bit bigger. Okay. Now what this is going to do is going to report back that our media room is on if at least one of these is true. So let's program this. All I got to do is go down here, select whatever variable level you want, and program the text tag. We're going to use the OR variable. But when the OR variable is true, we want this to say media room is on. And when the OR variable is false, we want this to say media room is off. Now again, let's see if this works. I'm going to go back and send this again. Let's send it to our virtual panel, which is the only thing that needs updating. Let's launch our virtual panel and then jump to our first page here. Now all three are on. So the media room is on. What if I don't turn on the cable box? Let me turn off the cable box. Same thing. The media room is still on because at least one of these is on. What if I turn off the receiver? Same drill. Media room is on still because the television is still on. But now if I turn off my television, now my media room is off. So you could use the logic helper to determine if any of your devices on your main floor or in your room or just about any kind of situation, maybe a TV in the sports bar is on, you can do that, okay? And you could see the logic gate table update accordingly as well. So that's what you can do with Logic Helper. I have a lighting control system, and it doesn't matter if my lighting control system is half one manufacturer and half another. I could have Lutron on for some switches and Z-Wave for others. It doesn't matter if you mix and match. All it's going to do is evaluate variables. It doesn't care if it belongs to the same device or not. Now, in our situation here, I've got a top floor and I've got a bottom floor, okay? And in this situation, the lighting control system doesn't give me a status for main floor on or bottom floor on or bottom floor off or main floor off. But I could use the logic helper to determine that for me. Now, I already went and programmed toggles on these buttons here. let me show you what I mean. I already programmed these buttons to toggle on and off. So this command will toggle this light on, and it will show its reverse state when that light's on. Same for all three. So these are just going to turn on and off the lighting zones. These lights don't know what floor they're on. They're just arbitrary lights in the system. Again, half can be Z-Wave, half can be Lutron. You could also stick in some other types of lighting in there. It doesn't matter as long as you have the variables. Now, in my situation, I want to know on my touchscreen if my main floor or bottom floor lights are on or if they're off. But I don't have that variable in the lighting control system. But I can use the logic helper to solve that problem. Let's show you how this works. I'm going to go to my logic helper driver again. And now I'm going to declare another Boolean variable. Okay? And we're going to call this Boolean lower level lights. And now you're just going to put your variables in for your lower level lights. So I'm going to go to my lighting control system, and I'm going to go to my main floor lights, and I'm going to evaluate light 1. Again, your lighting system might look different. Main floor light 2. Light 3. And light 4. So I'm going to evaluate 4 different lights using those operators. In my case, 4 lights here, but I could evaluate a lot more. In fact, I could even evaluate if all, using the logic helper, if all of the media room is all on or partly on or NAND or NOR as well. Okay? So you can add up quite a bit. But I'm going to evaluate if my lower level lights are on. So I created that Boolean myself. Now, let's go and program the logic helper driver. Let's go down here or on the interface. Okay? I already programmed the lights to turn on and off, which you have to do anyway. But for AND, let's program this like we did before. We're going to select source. Let's pull this screen up a little bit. Okay, for AND, I'm going to go to my text tag here, and I'm going to say if my AND lower level lights, if all of the lower level lights are on, well, AND will be true, and click OK. Okay, and then I can go here and change what it reports back. Instead of true and false, if AND is true, all lights on. If AND is false, all lights not on. Okay? Now, if I want to evaluate in a real situation, if at least one of these lights are on, like kids leave lights on all the time, maybe they play in the basement, come upstairs, forget to turn off the lights, now you'll know using OR. If any of those lights in that basement or lower level are on, OR will report back a true state. So let's program this as well. Let's select our text tag and let's evaluate the OR state. And let's make it report back some useful information. If OR is true, well, the lighting is on. If OR is false, lights are off. And of course, we could also use the not AND and not NOR variables as well. For NAND, let's go to our variable here, select source, click on the ellipses, and we're going to select NAND. And NAND, if NAND is false, all lights are on. If AND is true, all lights are not on. Obviously, in this situation, the OR and the NOR are going to be a popular bet. And for NOR, well, let's program this as well. And now when NOR is false, lights are on. At least one of those lights are on. If NOR is true, well, no lights on, at least on the lower level. And click OK. And then we're just going to program these. We're just going to go here and program a reverse state for AND or NAND or not AND and NOR, which are the inverse of NAND and NOR. Okay, pretty simple. Let's test this one out. Let's go and send this device as well. Send to our processor. And let's send to our virtual panel. Let's launch it. Let's give it a couple of seconds while our processor configures the logic driver. And let's select NAND or NOR. Well, wrong one. Okay. So right now, none of my lights on the lower level are on. So as I would expect, NAND is true because all lights are not on the lower level. And NOR is true because no lights are on. Okay? And as I would expect, AND and OR are both false. All lights are not on. And OR, well, at least one light's not on. So lights have to be off. Now, what if I turn on one light on the lower level? Now, all of a sudden, OR is true because now at least one of those lights the kids left on. Okay? And NAND is true because NAND is only false when all those variables are true. So NAND is going to be true unless everything has been turned on. Okay? And now let's turn on the second, same thing. Third, same thing. And now when we turn on that final light, AND is now true because all lights on the lower level are on. And OR is true because at least one light is on, of course. NAND is false because all these variables are true for the lower level lights. And NOR is false because one of these variables at least is true. So we just created a variable that didn't exist in the lighting driver, and now we can evaluate lighting. Let's look at other things you can do with Logic Helper. Let's shut these lights off. Let's return them back to their normal status, and let's close our window. Now, another thing you can do with Logic Helper is to check what the status is of those logic operators, okay? So I'm going to bring in a button. Let's make this a little wider, and let's call this lower level lights off. Okay, a little too small. Okay, so now let's give this a tag. We'll call it if else, because we're about to do an if else statement using those logic operators. Let's go to our macro level, pick source, and now in our macro steps, I'm going to bring in a system variable test. That is going to check what the operators are actually feeding back. Are they feeding back a true or are they feeding back a false? And this can act on that statement. So let's bring in the logic check. Okay, system variable test. And now let's select the logic helper. Now, what variable would make the most sense for both the lower level and media room level statuses? I imagine that we would want to turn off the lights if any of them are on. So we're going to use the OR for this case. And now you'll just, if that's true, if OR is true, that means at least one light is on. And now you can invoke a scene or turn off all the loads to however you need to. I'm going to bring in a command. I'm going to select my lighting control, my scenes, and pick the scene that turns off the lights on the lower level. So if the lights OR is true, at least one light is on, invoke the goodbye scene, which is scene 5. Else, well, we won't do anything. Okay? So that's, you can use Logic Helper, you could use system variable tests in Logic Helper to check if OR is true, if AND is true, if NOR is true, or if NAND is true. Okay? So whatever you want to use, whatever makes the most sense. If you wanted to check if all the lights are on, well, AND would be fine. Okay? Or you can do the opposite. Just remember that then this statement says, hey, are one or more variables false? If they are, I'm going to run this. So it doesn't make much sense. Okay? And NOR is going to be true when all the variables are false. So you probably want to put this on that side. Okay? So there you go. System variable tests. Okay? Now you could also show some text-based feedback of the status of your lower level lights using the AND or NAND or NOR. So I'm going to take my pencil and I'm going to draw a text box. Okay? And I'm going to edit text. And I'm going to insert a text tag. And this text tag is going to do a check of my lower level lights. So I'm just going to label this lower level status. Okay, that sounds good. Let's make the font a little bit bigger, make it bold. And now let's program this. I'm going to program a source variable next to the text field. Click the 3 dots. And now with our Logic Helper driver, pick the option that makes the most sense. I'm going to go with the OR option because I want this thing to show me if any lights are on. I want that to be true to show me some feedback. Now, false is not going to be helpful or true. So let's go and click edit and let's change these to what they should really feedback. Let's call this lights are on or lower level lights on. And if it's false, that means that no lights are on, lower level lights off. Okay? And there we go. Now, a lot of times, you might not want to have this always on the interface. It takes up room. It's tough to just have to watch this, even though the lights are off. Maybe the kids aren't home. Maybe they're at school. Why should this even be on your interface, right? So what if we wanted this to pop up only when at least one of those lights are on, or all the lights are on, whatever you want to do, okay? Well, Logic Helper also has driver events. Let's click on the Logic Helper driver under the driver tab. And now I'm going to select driver events. Okay? And here's a list of all the events that are available with the Logic Helper for at least the Booleans we created. Okay? So with the lower level lights, you'll see AND, OR, NAND, NOR. Same thing with the media room power. And the great part about this is that this is a rolling status, which means as soon as the condition changes to any of these operators, so as soon as that last light gets turned on and now all the lights are on, this will ring true and you could trigger a macro. Same thing with OR. Of course, NAND will be true when everything is false, and NOR will be true NAND will be true when one or more lights are on or off, and NOR will be true when all the lights are off. Okay? So let's use OR. And what I'm going to do is I'm going to set a flag, which is going to ultimately pop up that message on my screen. Pretty easy to do. Let's select OR. And now I'm going to go down to my macro window and I'm going to click the flag, edit flags. And I'm going to declare my flag. So where flag 2 is here, let's call this lower level lights pop up. Okay? Because this is going to pop up when one of those lights or two or as many lights are on. As soon as that first light in the lower level gets turned on, you're going to see it pop up. Okay? And let's click OK. And for the energy conscious, this is going to make a lot of sense, especially in large homes where you don't want to walk to the other end of the house just to do a light check. Okay? All right, so when OR is true, what's going to happen? Well, we want to make sure we set that flag. So in my macro steps, I'm going to bring in my flag statement. I'm just going to bring that in. Okay? And now what do I want to do? I want to select the right flag, my lights, and I want to set that flag when OR for the lower level light Boolean is true. Okay? Now that should trigger a pop-up. We have to still program the pop-up, but this should take care of what we need for the pop-up. Now, we also want to make sure that the pop-up goes away when we don't need it. Okay? And the only way to do that is to clear the flag. So which one of these would make sense when all the lights turn off now? We want to make sure that that will trigger. So I'm going to go with the NOR one. NOR is going to be true when all the lights are off and false when one or more lights are on. So if NOR is true, that's got to mean that every light is off. So now I'm going to bring in that flag again. Select my flag and clear the flag. So let's recap. When OR triggers, when at least one light's on, the flag lower level lights pop up will be set. And when NOR is invoked, that is when all the lights are off, this will invoke, which will clear the flag. Now all we have to do is create the layer. So I'm going to go back to my interface. Okay. And now what I'm going to do is I'm going to create a layer. Okay. And I'm going to call the layer lower level light pop-up. Now I know exactly what it does. And when do I want this to be visible? I'm going to click the ellipses next to the visible state, and I'm going to pick that flag. So when that flag is set, that layer will be visible. When that flag is cleared, well, that layer won't be visible. It'll hide. Okay? And click OK. Now that we've programmed the layer, let's move this to that layer. Okay? So I'm going to right click, move to layer, lower level pop up. Let's put that as up here. And as soon as that light is on, one of these lights on the lower level get turned on, whether it's one or all four or three of the four, that is going to pop up. Okay? But as soon as that last light is turned off, that it will go away. So theoretically, the client shouldn't even see the all lights off ever, but it's okay to include it. Okay? And there we go. So you can use driver events in your installations. Pretty cool. Now let's talk about some of the limits and some of the caveats of using Logic Helper, the do's and don'ts. Now, with the Logic Helper, let's click on the Logic Helper driver again. Click on driver properties. The Logic Helper driver will allow you to use 16 Boolean variables. Okay? So we are using 2 right now, the media room power, lower level lights. Okay? And underneath those Boolean variables, you can use 16 status variables. Okay? So it's a 16 by 16 rule. Okay? 16 Booleans, 16 variables underneath. This is using 3 of the 16. This is using 4 of the 16. Okay? Now, we all know that sometimes, especially in large businesses or residences, right? Lower level lights might mean way more than 16. Okay? How do you evaluate that? Okay, let's pretend that on my lower level lights, I've exhausted all 16. And now I've got 16 more, 32 more, however many more. Okay, but we ran out of variables. What could we do? Okay, well, what we could do is create another bank, right? So let's call this lower level lights 2. Okay, and then you'll put in all your lights on that. I'll just use this area here. I'll just throw a few in here. We'll pretend there's a lot more. Okay, and you'll use up as many as you need. Okay, now, how do you evaluate this? Well, you're going to create a third Boolean, and we're going to call this all lower level lights. And what we're going to do is evaluate the logic helper variable. How does this work? Well, we're going to pick from the Boolean 1, from the variable 1, we're going to pick the logic helper to evaluate. And we're going to go with the lower level lights, or now, if any of those lights on this bank are true, this all lower level lights becomes true. But we're also going to evaluate the second bank of lights. And the only way this variable will be true is if one of these lights on the lower level of on from these two banks. So you could use as many as you want, just follow this 16 rule. Technically, you can add another logic helper driver. Just be careful because it could slow down the system or even panel. So be careful with that, okay? So you can use the logic helper as an underlying variable as well, okay? And you could use all 4, AND, OR, NAND, or NOR, okay? All right, another thing that you have to be a little bit careful about, besides limits, are view-based variables, okay? I've already put this in here. Selected room, for example, okay? Now, with a selected room variable, something like system manager, let's say selected room is kitchen, okay? Maybe also system manager, the selected room is the media room. You have to be careful with these types of variables. This isn't going to work because this is a view-based variable. Why is this a view-based variable? Because you could select a room on one controller and select a completely different room on another controller, even if technically they're controlling the same room. So this is called a view-based variable. It's controller-based, okay? And what that means is it's more about a specific view available only on one controller, okay? Because if you select a room on one controller, wouldn't it be lousy if all the controllers in your business or home selected that same room? So that's called a view-based variable. In order for logic helper to work, the variables have to be processor level variables. For example, the flags, the system variables. These are known to the processor, no matter what panel you're on, okay? They'll all know about it. But these two on the bottom, well, you want to be careful with these. This will not work, okay? So don't use view-based variables. If you ever have problems not getting right input, or not getting right output, I should say, make sure you're not using view-based variables. You might be and might not even know about it. So always ask yourself, is this variable always going to be true on all the controllers, or is it just going to be one controller at a time? If you're not sure, just check with us. All right, so that's the logic helper driver. We've covered how to understand the variable levels and all the different options you can use. Again, logic helper is designed to evaluate a group of variables using logical operators, AND, OR, NAND, or NOR, and of course, false when one or more variables are true. Okay, so it's just going to be the opposite setting as far as true false as the OR. Okay, we've covered the system variable tests. We show you how to use text-based feedback and other types of feedback as well, button state feedback. Okay, we also showed you how to use driver events. Okay, we showed you how to pop up a driver, show off a driver event based on one of the statuses, and we explained the limits and the caveats. And that's the Logic Helper driver. Pretty powerful. Keep practicing with it. If you ever have an issue where you need to evaluate a group of variables, think Logic Helper. All right, that's all I have. Thanks so much for watching. We'll see you next time.